Hi guys, my presentation for tonight is this pre-stowage plan. Is departure draft on at Port Dampier is 18.23 forward, up, and midship or mid draft. So his Even Keel and his ROB is fuel is 1050, his DO is 50, his freshwater is 300, his ballast is 100. This is the unpumpable remaining ballast, and his constant is 385. His cargo, his cargo is 206,000 metric tons. So that is his departure draft at Dampier. We will try to make a draft survey on this figure. So we'll make a draft survey. And here we put 18.23 forward, port starboard 18.23, midship 18.23, port and starboard 18.23, and up is 18.23, port and starboard is 18.23, and the density is 1.025. The density is 1.025 in Dampier, Port Dampier, and also in Gwangyang, Korea, South Korea is 1.025. So we put the 1.025. Now we go down to the ROB. His fuel ROB is 1050. 1050 is diesel oil is 50. Diesel oil is 50. And his ballast is 100. Ballast is 100. And his constant is 385. Constant is 385. Store is 385. Okay. So his total cargo on board is 206,032 metric tons. So he's over about 32.6 metric tons. So that's good. It's not less of the amount, but just a little bit over. That's fine. So, okay, we proceed. And in arrival to Gwangyang, South Korea, he maintains the draft of 18.23 forward, up 18.23, and mid drop is 18.23. He wants to maintain this drop on arrival at Gwangyang, and his ROB is FO is 470, and his DO is 48 metric tons. He has a production of freshwater is ROB is 320, and his constant is the same, is 385, and his density is 1.025. Now, travel time from Port Dampier, Australia to Gwangyang, South Korea, the distance is 3,526 with a laden speed of 12.4. How long will it take to reach Gwangyang? So, 3,526 divided by 12.4, you will get 284.35 hours. So this figure, you divide it by 24, so you will have 11.8481 days of travel. And this number of days, you multiply it by the consumption of 49 metric tons per day. So you multiply this to 11.8481 days, you have total consumption of 580.6. So he's got here 580, so we stick to this figure. And in 11 days and 11.8 days travel, the consumption of diesel is only 2 metric tons. And in freshwater, he can produce 20 metric tons of freshwater in 11.8 days. And he wants to pump in 500 metric tons before arrival Gwangyang. So we will see what happens here. Okay. We start from here. This departure ampere is 18.23. 18.23. Departure here is 18.23. 18.23. Ano nangyari dito? Okay, put here 18.23 and 18.23. Okay, and here 18.23, 0.23, 18.23. Okay. Now, we have we don't ship cargoes, so we take this out. So we have this one. Copy. Paste. And to copy. And the LCG of number one is 111.93. 111.93. And the starboard side is 112.81. 112.81. Okay. Is freshwater. Port side is freshwater. Okay. Freshwater is the LCG is 136.19. 136.19. And is DO on number one. Copy. And LCG is 121.73. 121.73. Okay. And what else? And after peak copy. Is LCG is 137.38. 137.38. Okay. Now, we go back to the pre-plan. This pre-plan is consumption is 580. So we divide this with 2 equals divide by 2. So 290 in its tank. So we put 290 in its tank. Negative 290 because it is consumption. And we got here negative 290. So the total voyage is when he will reach Kwanyang, he will consume about 580 metric tons. So this is it. With these 2 tanks, he will consume about 580. And he has a production water of 20 tons. So it's positive. And he has a consumption of 2 tons negative. Okay. And he says he will add 500 metric tons prior to arrival Gwangyang. So we put here 500 metric tons. 500, that is positive, because he will pump in. And this will be his condition when he arrives Gwangyang. It's almost even keel. His final drop is 18.22, updraft is 18.23, and his mean is 18.23, or his mid is 18.23. So it's almost even keel. His stream is 0, so it is his arrival condition is correct. So he got his target correct. Forward 18.23, up 18.23, mid is 18.23. You have the 0 trim, and that he got the exact arrival. Okay. Now, there's another way of computing. There's another way of computing to reach Gwangyang without using the ballast tank. You have 2 choices. You can use the ballast water, and the other one is without using this ballast of 500 metric tons. So I will show you how to do it without using the ballast tank, but we will arrive at Gwangyang at even keel. Okay. So let me go back to the history. Sorry. And we go back here. Okay. During our loading operation, this is just an example of the loading plan or loading sequence. This figure is a little bit higher of 200 metric tons, but we will use this as an example. Okay. So after pour 18, the shipmate and the surveyor, draft surveyor, take around the ship to take soundings around the vessel. This is what they have agreed. Let's say forward 1789. Forward is 1789. Here 1789, and up is 1805. Put here 1805. 05. And your mid drop is 1797. You have zero trim, and 19 is the hold, trimming hold. So we have 1797, 1797, 1797, 97, and 17.97. And your final mid departure is 1828. Okay. So the recommended cargo to load, remaining cargo to load, is 3606.5. So I put here 3606. Okay. When you put 3606, the mid drop is the same with this one, and the rise and sink is the same with this one. So now we will distribute on the cargo to holes 1 and 9. Okay. Cargo to load is 3,606. And how much would be we load in number 1? Number 1 is, if zero trim, number 1 is 1821. Okay, 1821. I put here 1820. Up will be, number 9 will be 1786. Okay, 76. So your drop departure will be 1823, 1823, forward and up, and your minuscule. So you have an even keel. This is now the thing. On the later part, we use the ballast for arriving in Guanyang. How is it? Okay. Good. Now, in arriving, we have a fuel oil of 580 to be consumed. So in this fuel tanks, once this 580 metric tons will be consumed, the tendency of this part will rise up, and the tendency of this forward will go down. So to maintain this upright position, so you will have to load at the after peak of 500 metric tons to maintain this upright position. So when arriving in Gwangyang, when you put at the after peak of 500 metric tons, you will maintain this upright position. So that is the reason why we have to load 500 metric tons. But there's another way of maintaining this upright position without putting ballast. And this is the way how you will do it. Okay. Now, in in my experience from Australia going to Japan, if you want to arrive even keel in Japan, you should have a trim of 20 centimeters or 0.20 metric meters. So it is also the same with Korea. If you came from Australia, let's say Dampier, and you will go to Gwangyang, you should have a trim of 20 centimeters or 0.20 meters. When you reach Gwangyang, you will have an even keel. So how do so we will find out how much we will load in number one and number nine to have a 20 centimeters trim. So in the two holes in the final trim, you put here 0.20 centimeters. When you already put this 20 centimeters trim, how much will the program say you will load in number one? Number one says you load 1539. Okay, 1539. Put here 1539. 1539. And on the up part, you will load 2067 or 2067. And how much will be your arrival departure drop? So this will be your departure drop. Your departure drop will be forward is 18.13 and up is 18.33 with a trim of 0.20 centimeters or 0.20 meters. And your main will be 18.23 or your main will be also be 18.23 with zero deflection. So we will take this draft forward and up. Forward is 1813 and up is 1833. 1813. So put here forward is 1813.13 and up is 18.33. Your mid will still be the same 18.23, 18.23. Now, so you will take out this ballast because you will not be using the ballast. You will still be consuming about 580 metric tons for one tank. You would consume 290, and starboard side you consume 290, and you will produce of 20 tons freshwater and consume of 2 tons diesel oil. And your arrival drop at Gwangyang will be 18.19. Forward up will be 18.19 up, and your main will be 18.19, and your deflection will be. So this will be your arrival at Gwangyang 18.9. Now we will make a drop survey of how much cargo we will still have if we use this drop. Okay, so we use the initial drop survey. 18.10, 18.10. Egypt is 18.10. Starboard side 10.19, up 18.19, 18.19. Okay, we have done the arrival draft. The density is still the same, 1.025, and we will now put the ROB. The remaining fuel is how much? 470 fuel oil. 470, 470. Diesel oil will be 48 because 2 tons consumption, and the ballast is remaining ballast is still 100 because you did not put ballast. You know, freshwater is 320, 320, 320, 320, 320. From the straight flaps. So your total cargo on board is 206, 139. So you have 139 more cargoes on board on your uh, initial draft survey upon arrival Hwangyak. So that's it. I hope you got the point what I'm aiming about. Either you could use the ballast upon arrival to get an even trim, and use the cargo to have a trim of 0.20, and you still have maintain the cargo and uh, have an even keel. But how did I get this figure of figure of figure of 18.19? 18.19. Okay, let's do the arithmetic. You have a TPC from the drop of from the present drop of 18.23, which is 138.71, and you have a rise of 0.041, meaning you have a rise because you are consuming consuming fuel oil FO, so that your vessel will rise. So you have a rise of 4 centimeters, 4 centimeters, right? So by mathematician or mathematics or algebra equals, you have a trim of 138 equals 138.71. You divide it by 100, 100 divide by I'm sorry, the total consumable fuel oil was 500 500 580 plus 2, that is 582. Okay, so equals 582 divide by 100 divide by your TPC 138.71 equals, this is your rice, which is which is equal to sinkage or rise is 0.41. So this is 4 centimeters that the vessel will rise. So if you have a uh, target of 18.23, if you vessel will rise, so you will uh, deduct it from the arrival drop. So let's say was 18.23 minus the rise, which is 4 centimeters, then your arrival drop will be 18.19. So this is how you get 18.19 because of your consumption of the fuel oil, consumption of the fuel oil and this diesel oil, which is 582 metric tons. So I repeat, 582 metric tons divide by 100, then you divide again by the TPC, which is 138.71, 138.71 equals, oh, I'm sorry, equals here, and the answer is 0.4196, 4 centimeters, and 4 centimeters was 18.23 minus 4 centimeters. Your answer is 18.19. Okay, so this will be your arrival drop at Wangyang, forward and up, and mid is 18.19, and you will have a trim of 0, and your deflection is 0. I hope you got this straight. You understand this mathematical computation. If you have any questions, don't hesitate to ask and send a message or make a comment on the description down below. Thank you very much and have a good day.